Hello, Wanakam, welcome, good evening, Marhaba, Sat Sri Akal, my lovely warriors. Hi Shruti, hi Ritesh, hello Sri, hello Ravi Teja, Moana, Nitesh, Mulapo, Mki, Avangati, welcome Kavya, welcome everyone, welcome to the Zero to Superhero series. And today's session is all about giving you those notes, my handwritten notes. Also, I'll be giving you the mind map and I'll be solving problems. So this is mainly a problem solving session through which you will understand the concepts of the kinematics, 1D, 2D as well as the relative motion. So I hope you guys are all set, ready and ready to rock in this session with me, Shreyas, your physics master teacher. And guys, welcome to JEE Enlite as well. And if you want to know more about me, you can follow me on Instagram. You will find all the details. So thank you for hitting the subscribe. Thank you for hitting the like button. It means a lot. Thank you very much. And on the Telegram channel, I'll be giving you the entire PDF of today's class. Okay. So let me just check all your doubts meanwhile. Just one sec. Let me just get you on the screen. There you are. Yep. Hello. Crack with Gokulnath, Sri Sant. Captain. Good evening. Good evening. Happy evening, everyone. Super duper excited, says Dinesh. And guys, the theory part in kinematics is not so much. It's mainly the basic formulas which you should know. I'll just quickly glance through it because I feel that we should solve more problems, because anyways formulas is something which you need to revise again and again. Okay, so the weightage of the chapter roughly, well, Abhi, it's not much, honestly speaking, but the concept of kinematics and projectile motion can come in different chapters. Like, see, kinematics can even come in magnetism, even in electrostatics, even in gravitation, even in Newton's laws. A block is left, you have to show the forces, find acceleration, then find how much displacement it does. So indirectly, the weightage is very huge because component splitting, resolution, projectile motion, the concepts can be used anywhere. Relative motion, so many places, right? So that's the reason why individually the questions will be very less, but as a combined concept, it is huge. Yes, Telegram is free, Mulapudi Bhushanam. It is definitely, bacha. The JEE Mains 2023, I feel February end or March. Okay, so let's begin. Hi Gaji, hello Jones, welcome everyone. So let's begin with the class, and thank you for smashing the like button. In case you haven't, please do that right now. Like I say again and again, why is mind map very important for any chapter? It's because it gives you a holistic picture at a glance of what all is there. You can revise it while sleeping. Acha, this motion in a straight line, position, displacement, what is velocity, what is acceleration, what is frame of reference, what is this, what is that, graph. So that way you don't have to see things, you can just revise mentally, and if you skip a thing, you know what you have skipped. Now this is not the exhaustive mind map. You can make your own mind maps. This is something for you to understand that how mind maps are made, but you can extend this. Even in this branch you can extend more, even in this branch you can extend more. Please let me know how many of you are actually making mind maps for chapters. At least 1 or 2 chapters have you made mind maps, and do you see the usefulness of it? Maybe you did not find time for other mind maps, but did you make mind maps at least for 1 or 2 chapters? Yes, Avi studied, there will be advanced series. By the way, your Dynamite series is kind of advanced only. It's the easier questions of advanced and tougher questions, toughest of the questions of mains. So it is a bridge between the two. Those kind of questions can come in advanced, okay, but there will be a special advanced series on this channel also. Okay, so if you have not made, please start making. See, this is different from notes. A lot of people get confused. Sir, notes I have made isn't the same thing. No, notes is different. This is different. In this, formulas don't come. Formulas will not come. Only the heading, the titles, subtopics, concepts. Acha, concept 1. Variety of problems. SHM can be solved by this way. So, methods, titles, topic names, that is what comes in mind maps. So, don't confuse between short notes and mind maps. They are two different things. Short notes can look like this. I'm going to give you my short notes. Position vector. A particle is going in a path. This is x-axis, this is y-axis. Where the particle is, that is the position vector. Change in the position. What is the change in the position called? Hi exam now, welcome aboard. Yes, correct, Harish. It gives you an idea of what it is. India Lakshmi has made it for few lessons. You can try it out. Well, if you are 2022 aspirant, I think you have very little time. But if you can make it for at least the main chapters, maybe not all chapters, that will be good. Especially those chapters where you keep forgetting things. Yes, displacement. And displacement is final minus initial position. You can see this is final, this is initial. That is delta S, which is the displacement. And you can see that we can write displacement is final minus initial. So final is taking this over here is initial plus the displacement. That's the same thing. Average velocity is the total displacement upon total time. Instantaneous velocity is the smallest of the displacement in the smallest of the time interval. Very, very important. ds by dt and delta. Do you know what is the difference between delta and d? What is the difference between delta and d? The difference between delta and d. Delta can be anything. It can be 1 second, it can be 100 seconds, it can be 2 hours. But d is an infinitely small value. So it's always going to give me instantaneous values. That's the difference. Okay. Can we get especially any branch having only physics in any NITs? Oh, Abhi, I'm not sure what you mean by that. There is nothing like physics as a branch. It's MSc physics and it's not there in NITs. It's only there in IITs, ISTs, ISERs and ISC. Okay. The magnitude of velocity is speed. That's something which you should know. Again, the definition of acceleration, you should know rate of change of velocity. I've put up everything. This is one particular case which I want you to pay attention to. If you're accelerating in the same direction as velocity, if you accelerate in the same direction as velocity, speed increases. If you accelerate opposite to the velocity, the speed decreases. Like when you throw a ball up, speed is up, acceleration is down, the speed will decrease. If it is perpendicular, like in circular motion, the speed will not change. It's only the direction which changes. Something which you should know. So if you have acceleration and velocity, that acceleration along the velocity changes the speed like it is shown here, and the perpendicular one only is responsible for the changes in the direction. Again, average will be delta v by delta t, total change in velocity by total time. Instantaneous will be dv by dt, something which you should know. Okay, and whenever you have delta change, it's always vector subtraction. Remember that. Change in anything, final momentum minus initial momentum, delta p. So it's always vector subtraction. Okay, now kinematic equations, everybody knows V is u plus at, S is ut plus half at square. Now this is a tricky one. Many people do not remember what is the vector form of this equation. The third equation, kinematic equation, yes, it is V square is u square plus 2s in 1D, but in 2D or 3D, then you have to use this one. V vector dot V vector is u vector dot u vector plus 2a vector dot x vector. It's a dot product. Okay, it's not a pure multiplication, something which you should keep in mind. In nth second, what is your displacement is u plus a by 2, 2n minus 1. What is the meaning of nth second? In case some of you would have forgotten, what is the meaning of nth second? Say for example, I tell you, what is the displacement in fifth second? Fifth second. That means how much have you moved in what to what? Think about it. You have moved from 4 to 5 seconds. That is the meaning of fifth or any nth second. In the previous second, how much you have moved. If I say 7th second, how much have you moved from 6 to 7? If I say 10th second, 9 to 10. So the previous 1 second, how much you have moved. Remember one thing, kinematic equations are only valid for constant acceleration. If acceleration is variable, then you have to shift to derivatives and integration. It's valid for both 1D, 2D, 3D, everything guys. That's something which you should keep in mind. Standard formulas which you should know is when you throw a ball up and it comes down, the total time of flight is 2u by g. So it takes u by g to go up, u by g to come down. And if you drop a ball from here, the time it takes to fall down is root of 2 height by g. Okay, two important formulas. Similarly, the maximum height which it goes is u square by 2g, and the speed with which it hits the ground is root of 2gh. Standard formulas which you should know over here. Now, You should also be very well aware of the vector resolution. Okay, abhi the dot product. So basically this is the the derivation is there. After you derive, this is what you get. So when you write v square or any vector square, what does it mean technically? See, if I say a square, if a is a vector, it means a vector dot a vector, because a vector dot a vector is basically a into cos of 0. Cos 0 is 1, so that's why it becomes a square. So actually speaking, v square is v dot v, a u square is u dot e. So that's how it comes actually. Okay, fair enough. Now in resolution, you should know what is components, how to write the vector, how to find the magnitude. Very important, because in projectile motion, obviously it's all about components, cos component, sine component, etc. You should also know the sine, cos, tan of all the standard angles, 30, 60, 45, 90, 0. The special angle, which is 37 and 53, there is a very easy trick to remember that. Look at this. Look at this. This is a 3, 4, 5 Pythagorean triplet. Everybody knows this, right? 3 square plus 4 square is 5 square. So if this is 5, this is 3, combine them together, this is the angle between them. Look at that. 5 and 3, 53 degrees. So what is the complementary of 53? It is 37. So once you draw this triangle, it becomes easy to find anything. Let's say sine 37, opposite by hypotenuse, so 3 by 5. Tan 53, opposite by adjacent, so 4 by 3. So cos 53, 3 by 5, adjacent by hypotenuse. So it becomes very easy to solve the questions. Okay, so component finding, very important, vectors. Next thing is a trick which is used for finding the angles in many situations. Many times you get confused which is theta, which is not theta. So usually I tell people to divide it into 8 parts, and mark any angle as theta. Every alternate angle becomes theta. Every alternate angle becomes theta. And we also know that when you have two parallel lines, these two are the same angles, and this angle are also equal. An example for this would be, let's say, imagine you have a situation where there is a wedge like this. Maybe there is a mass over here, and you're interested in free body diagram, velocities, accelerations, forces, etc. So what you should do is always divide it into 8 parts. So how will the 8 parts look like? One is perpendicular to the surface, second is along the surface, third is horizontal, fourth is vertical. Horizontal, vertical, along, perpendicular. Now let's say I tell you this angle is theta, for example. If this is theta, I hope you see this is a parallel line. This is also a parallel line, and this is a line which is intersecting both of them. So if this is theta, naturally even this is theta. It's just like this. If this is theta, this is theta. So if this is theta, so you will see even this is theta for that line. Once you know this, look at this diagram. Every alternate angle becomes theta. So if this is theta, this is also theta, this is also theta, this is also theta, this is also theta. So you can mark it. Now it becomes very easy to resolve any vector. Okay, I hope this is clear. But yeah, Pranav, I'll definitely try and put it. So very important properties related to trigonometry and some short tricks which you should know. Second thing, in 2D motion, you should know projectile motion formulas, like when you throw an object with some speed, at the highest point when the vertical component becomes 0, the maximum height is given by u square sine square theta by 2g. When it hits the ground here, the time of flight is 2u sine theta by g, and how far it falls is u square sine 2 theta by g. Also you should know that the range is going to be maximum for 45 degrees projection. So when you project it at 45 degrees, it falls at maximum range. But if you have complementary angles, then the range is same. For complementary angles, the range is same, like 30, 60, same range. But time will be different. So 30 and 60 will make it fall at the same place. 20 and 70, same place, but times will be different. That's all. There is also one more genre of projectiles where you throw a projectile from some height. So if you throw something horizontally and it falls here, the time that it takes to fall is exactly similar to that of this one. when you drop something, the time it takes is root of 2h by g. Look at this, when you drop something, the same time is also there when you throw something horizontally from some height h. Range, horizontal distance, is horizontal speed into time. And also remember, horizontal speed never changes in projectile motion, because reason, there is no acceleration in the x direction. Always acceleration acts downwards. So that's why velocity in x direction always remains constant, be it this kind of motion or be it a motion from the hill. Yeah. So complementary angles, MK, is angles which add up to become 90. Supplementary is when the angles add up to become 180. Like 20-70, complementary, correct? 45-45, complementary. 30-60, complementary. Supplementary is when it is 180, like 100 plus 80 is supplementary. Hello, Indu Kanan. Okay, so these are all your notes which I am giving you. Also, I am giving you the notes of relative velocity, like velocity of some object with respect to some object. Relative velocity. So when I say relative velocity of PC, Pandu and Champa are moving, it means you are finding Pandu's velocity sitting on Champa. When I say velocity of Champa with respect to Pandu, it means I'm sitting on Pandu and seeing how Champa moves. That's how you order it. VPC is velocity of Pandu with respect to Champa. Formula wise, it is VP minus VC. If I say VCP, it is VC minus VP. Like you can see, both are opposite of each other. So VPC is negative of VCP. So the magnitudes are same, just their directions are opposite. 1 with respect to 2, 2 with respect to 1, equal and opposite, always. Also, remember that whenever you know velocity of something with respect to something, that something with respect to something else, that something else with respect to something else, especially rain man, river boat, man swimmer problems. So in those cases, remember this trick. Very important chain rule kind of a trick, which says, let's say I want to find the velocity of donkey with respect to monkey. DM, velocity of donkey with respect to monkey. So always start with the first alphabet, D. So let's say you know velocity of donkey with respect to zebra. Donkey with respect to zebra. You end with Z, start with Z. Velocity of zebra with respect to horse. I don't know. You ended with horse, start with H over here. Velocity of horse with respect to cow. C ends, C starts. Velocity of cow with respect to the last letter, M. So if it is 1, 2, start with 1, end with 2. In between you can have multiple letters, multiple frames. Change the frame in order. VDM is VDZ, ZH, HC, CM. Start and end with the same 2 alphabets. Got it, guys? Oh, my coolers, I forgot about it. Okay, I'll just put it, maybe I do. I'll have to search for it. I don't know where I kept it now. Okay. Also remember, whenever you use this, it's actually vector subtraction. So vector subtraction, which you have learned in vectors, is actually vector addition. So when I say VP minus VC stands for negative velocity of Champa. This is Champa. You can see she's wearing this beautiful red lipstick. So VC is here, flip it. So adding negative velocity to VP will give you VPC. So VPC is VP minus VC. So minus VC has to be added. And when I similarly say VCP, it's VC minus VP. That means velocity of Pandu has to be reversed and added to Champa's velocity. VC minus VP. VC minus VP is VCP. That's how it goes. Okay, quick revision. Thank you, Jagan, so much. Yes, sir, we are going to come to riverboat questions also. Now, rain man. Okay, I don't think we need this. Oh, I can't erase it now, maybe later on. Okay, so ignore this top part. VR is velocity of rain man problems. VM is velocity of man. And generally the question is, how are you going to hold the umbrella? Or it is given that the rain feels like it is falling at certain angle. What is the velocity of rain? So these kind of questions, it's 90% of the times a geometry question. Simple triangle with Pythagoras or trigonometry gives you the final answer. So you should remember 3 things. VR is how actually the rain is falling. VM is how the person is moving or how much he is moving. VRM is the perceived, how he feels the rain is falling or how he should hold the umbrella. Now, what happens is, good evening Bharti, good evening everyone. VRM, V12 is V1 minus V2, I just told you about it. VRM or V12 is V1 minus V2. So VRM will be VR minus VM. So if you know the rain is falling this way, person is traveling this way, VR minus VM. So negate which vector? It is a negative of VM. So VM vector has to be inverted. VR vector you flip, VM vector you flip it. This is minus VM. Forget this now. Just use triangle law. VR minus VM gives you VRM. Simple. This plus this gives you this. So that is VRM. So this green vector tells you how the rain feels like coming. So you are going to hold your stick of the umbrella along this VRM direction. Yes, God is love. The crash course prices are going to increase tomorrow onwards. मैं बढ़िया हूँ भार्गव कलम्बे. Okay, and the crash course prices are increasing tomorrow onwards. That means from June 1st you will see new prices. Next thing is river boatman. River boatman, or sometimes it's swimmer versus river thing. Now, in these kind of questions, there are again three things just like the rain man problem. So what are those three things? Number one, the river will be flowing with some velocity. I'm just going to call it W. It is the actual velocity of the river. How much is the river flowing? That is W. The banks are situated at a distance of D from one another. U is how much the swimmer swims with respect to still water, as in a swimming pool where the water is at rest. So in the still water, what is his velocity? But V is the final resultant velocity, including the river flows effect and the swimmer's effect. So if the swimming pool is at rest, obviously the water is not moving anywhere, the swimmer moves with some velocity. Now if the swimming pool itself is moved, obviously the resultant velocity will be a sum of both of them. So V is W, river velocity, plus the swimmer's velocity, which is trying to swim in that still water. Is that making sense? Okay, and if you look at it vectorially, if I know the water velocity, if I know how the swimmer is trying to swim or how is he making his strokes, then this gives you your final velocity using vector addition. A vector plus B vector is C vector, as simple as that. Okay, now there are two major cases in this. First case is when you want to cross the river in shortest time. Second is when you want to reach the opposite side in the shortest distance. Whenever it is shortest time, you are going to try and swim in the perpendicular direction of the flow of the water. You will try to swim here, but because the river is flowing, you will end up reaching here. That phenomena is called as drift, because you want to reach here, but you end up reaching here. So you have drifted away, and this will be your final velocity, again using your standard vector addition. My swimming velocity plus the river velocity gives me the resultant velocity, so I reach here. So my time taken to cross is this distance, which is D, upon the speed in this direction, which is U. So D by U is my time, and this drift, because it's horizontal, it is how much time I take into the horizontal speed. Horizontal speed is W, as simple as that. Okay, that's shortest time. For shortest distance, always try to swim against the flow so that you compensate the river velocity. So U is here, so you're making the stroke somewhere here, such that the resultant of U and W comes out perpendicular, and you end up going exactly perpendicular to the flow of the river. You can see by triangle geometry, sine theta is opposite by hypotenuse. So sine theta is W by hypotenuse, which is U. And also the time taken to cross this much distance, this distance is D, the speed in this direction is V. So D by V is the speed. Pretty much standard. These are the cases which you should know. Last few things before we start with some questions. Hello Ankit. Is the relation between position, velocity and acceleration, especially derivative and integration problem. Whenever you go down, it's derivative or slope. Whenever you go up, its integration or areas. Like velocity is derivative of position, which is also the slope of that graph, position versus time. Acceleration is the derivative of velocity, which is also the slope of velocity versus time. If you go up, the integration of acceleration gives you velocity, but if you put a constant, what is constant? Indefinite integration, right? So it will give you velocity, but if you put limits, what is that called? Indefinite? No, definite. Indefinite is when you have some unknown c, definite is when you have limits. That always gives you delta v, keep this in mind. V is indefinite, delta v, that is the change, so upper minus lower limit, that gives you the change. That is also the area under the acceleration graph. Area under acceleration graph gives you change in velocity. Same way, area under velocity graph gives you the change in the position, which is displacement. Keep this in mind. So again, integration of velocity gives you position. Integration of velocity with limits, that's definite, gives you change in the position. Pretty much standard, something which you should know. This is also a very important chain rule transformation. Acceleration is derivative of velocity with time. So you can cross multiply, or you can just multiply and divide. Multiply by dx, divide by dx, dx. Okay, now it cancels, so it gets back to the same thing. But dx by dt, that's velocity. So you can replace dx by dt as v. This is sometimes useful in certain questions. Okay, something which you should know. Shall we start with some questions, guys? Are you ready? Let me know in the chat box. In doubt session, how many questions maximum we can clear in that? It depends, bacha, how many students are there, how relevant is your doubt, how difficult or easy is your doubt, and all of that. Okay, so don't worry, you're going to get all these notes in the PDF form in our Telegram channel. Make sure you are a part of the Telegram channel. Okay, let's start with it. A body starts from rest with uniform acceleration. If the velocity after n seconds is v, then the displacement in the last 2 seconds is how much? Oops, I was not supposed to show the answer, guys. I'm so sorry. Ignore this. Now you know the answer, but ignore it. Let's try to solve it. Okay, it starts from rest. So at t is equal to 0, initial velocity is 0. So the question is, what is the displacement in the last 2 seconds? So t is equal to n, and let's say this is t is equal to n minus 2. So the question is, how much is this displacement? Okay, this is what I think they have asked. Let's try and do this. I'll be doing it. Yes, Krishna, obviously, but that was different language. This is English, this is Hindi. Sudan, yes, courses for 10th to moving 11th is coming this week. Just hold on for that. Sudan, something special is coming for you guys. Okay, so let's try and do this question. First of all, uniform acceleration is there. If velocity after n seconds, if its velocity after n seconds is v, so that means here the velocity is v. Let's try to use kinematic equation, which is v is u plus at. Final velocity is v, initial velocity is 0, acceleration I do not know, time is n, so acceleration is v by n. That's something which I just got. Next thing, since I want to find this part, this is this whole thing minus this thing. Till this n minus Sn minus 2 will give me the remaining thing. So displacement in the last 2 seconds is Sn minus Sn minus 2. See if you guys follow this. Does that make sense? Yes, something special, Sudan. See if this makes sense. Okay, this whole thing minus this thing, the remaining thing is Sn minus last 2 seconds displacement. What is Sn? It is ut, t is n, plus half acceleration into n square, minus Sn minus 2 will be u into n minus 2, that's ut, plus half into a into n minus 2 whole square. Now u is 0. Look at this, u is 0. So this is 0. This is also 0. 0 into anything is 0. So I'm just going to be left out with half a n square minus, this is 0. So half a n minus 2 square is n square a square plus b square minus 2ab. So plus 4 minus 2 2s are 4, 4 into n. Just check this out. Yep, does that make sense? Let's solve this further now. So I'm going to put it here after this. So it will be nothing but half an square. This is minus half an square plus 4a by 2 minus 4an by 2. an square by 2 cancels. So this will be nothing but 4 by 2 is 2 into acceleration is nothing but v by n minus 4 by 2 is 2 into a is nothing but v by n into n, I suppose. So one of the n just gets cancelled and I am left with nothing but 2v. Just check this out and I can take LCM. Oh, already LCM was there. Why did I even remove it? So 2v into, just check this out, n minus 1. Just check this out, n minus 1. Yep. 2v into n minus 1. Just check this out. No. Why you can't use the second formula? nth second formula? Read the question. Last 2 seconds. Displacement in nth second formula. This formula, where is it? This formula is only applicable for the last 1 second. There is a big difference in that. Okay, keep this in mind. Okay, fair enough, guys. Oh, actually, I think this minus also becomes, I think this will become minus, guys. I'm so sorry. Hold on. 1 second. This will become, oops, what just happened? Where is this now? Just 1 second. This was becoming, just hold on, minus an square by 2 minus, so this will be minus 4a by 2. This will be minus is plus 4an by 2. So these two people will cancel. So this will be 2 into a is nothing but v by n. This will become 2 and a is again v by n into n. So I think we can take 2v by n as common and here I will get minus 1 plus n. So that will be n minus 1 into 2v by n, which is option D. Yep. Okay. So I think that is the answer. Okay, fair enough, guys. Moving on to the next question. Let's see how many of you can do this. Funky boy, whatever the main topics are, I have just mentioned it at the start of the session. Just rewind back. I have put up a mind map. All those are the important topics. Hello Yogesh, hello IIT aspirant. Come on, join in. Okay, no problem, I don't know. What are the main topics in kinematics? I have already answered. Okay, let's try and solve this question. Very interesting question. What is it? A ball falls from height h. After 1 second, another ball falls freely from 20 meters below the point from where the first ball falls. Both of them reach the ground at the same time. What is the value of h? Let's draw this. So you drop a ball from a height of h. So basically this is h and it hits the ground over here and it takes time t. This is at t is equal to 0. You are leaving it. Now you drop another ball from here, but that is 20 meters below, and once you drop it, you're dropping it after 1 second, keep this in mind, and it falls by obviously h minus 20 meters and it reaches at the same time according to the given information. Reach the ground at the same time. Okay, let's do this part by part. If you only take this part where the ball falls by height h in time t, and I use s is ut plus half at square. S is the total height. S is the total height. Initial velocity, you're dropping it, so 0. Acceleration is 10, time is t, so hence h is nothing but 5t square. I'll just leave it at that. Next point. From here to here, how much time did it take? Remember, when you started throwing this ball, yellow ball, it took t seconds. But you are leaving this ball only after 1 second. And it reaches here at t is equal to t. So after 1 second you are leaving it. So here it is just going to take t minus 1. Total was t, this is 1 second, so this is t minus 1. Keep this in mind. So hence I can just say again using the same equation, s is h minus 20 is u is 0 plus half into acceleration into t minus 1 whole square. Does that make sense? Very good. Now h is nothing but 5t square, so just put 5t square from the top. So just put 5t square just from the top over here. Minus 20 is equal to 5. This whole expansion will be t square plus 1 minus 2t. So this will become 5t square plus 5 minus 10t, and here I have 5t square minus 20. This and this cancels. Bring this 20 here, bring this 10t over here. See what it becomes. So 10t goes there, 10t goes there, and 5 plus 20 is nothing but 25. So t is 25 by 10 divided by 5, so 5 by 2 seconds. Once I get time, because I think the final question is find the value of h. So we have to find the value of h. So from here, h will be equal to 5 into time square, which is 5 by 2 whole square. 5 cube is 125. 125 divided by 2. Oh, sorry, 125 divided by 4. 125 divided by 4 because 2 square. So I think it should be close to 30. Yes, it is 31.2. See if it makes sense. No, it is not A. Many people got it wrong. Some of you told A. It is C. Okay, it is not A, it is C. Moving on to the next question. Very interesting question. Let's see how many of you can get this. There is a ball which is dropped on the floor and bounces back to some height less than the original height. Which of the following curve depicts its motion correctly? Okay, which of the following graphs depicts the motion correctly? So you drop it, its velocity will slowly, gradually pick up. It's going to increase its velocity, and by the time it hits, it will have a large velocity. Very good. All right, come on guys, think about it. Now it rebounds back. But the velocity is slightly less because it does not reach the same height, somewhat less than the original. So think which of the graphs will be correct. Now in order to do this question, the logic I think you should use is, this is y coordinate, this is time. So slope of displacement time graph gives you what? What does the slope give you? Come on, put it up in the chat box. Hema, well, maybe I think you need to go through many chapters in excuse me, in a very fast manner, at least the main heavyweight topics. So please go through all the heavy chapters through one shots and the crash course. You have 2 attempts. Don't focus so much on the first attempt and lots of mock tests, because I feel priority should be completing chapters. Many people are saying acceleration. No, sorry. Many people are saying velocity. Yes, correct. So that's velocity, guys. Perfecto. Now, is the velocity same? Obviously not same. So velocity is changing. If velocity changes, obviously slope is changing. So all those graphs which have constant slope will get out. This is out, constant slope. Look at this, slope, constant. This is not even bouncing. Where is that bounce? So obviously gone. There is no bounce, it's bouncing back. Now out of these two, how do I decide? Let's see the part where it is coming down. So let's check the slope. So let's draw a tangent here. And after some time, let me draw another tangent here. Here, first time, it is very steep, then less steep. But it is going down, so negative slope. Let's say it is minus, oh my god. Oh, why is it going like this? Just 1 second, guys. We'll see. So now here the slope is going down a lot. So let's say it is, oh my god. It's a little bit tricky, guys. Hold on 1 second. Okay. Okay. So here the slope is a lot. So can I not say it is like -4 example? Here the slope is less. So let's say it is -3 or something. Magnitude wise it is 4. Magnitude wise it is 3. Slope is reducing. And what does the magnitude of the slope give? Basically magnitude of velocity. It gives you speed. It gives you speed, the modulus. So think about it. Here the speed is reducing. Here the speed is reducing. That is definitely not the case, because I know speed actually should increase. Speed should go up. If you notice here, if I draw a tangent here and here, let's say the slope is -3. Here it is more negative, it's -4. Magnitude wise, which gives you the speed, it has definitely increased. So this should be the correct graph. Option B it is. Understood? So the magnitude of the slope, which is velocity is magnitude, gives me speed. That's the understanding required. Otherwise there is hardly any difference. Yeah. Okay. Slope is steeper. MK means see, this is zero slope. This is positive slope. This is more positive. Okay. It is steeper. Here it is negative. This is even steeper, so more negative. So that's what steepness means. It is either more positive or more negative magnitude wise. Good evening, Khushi. Welcome. Very good conceptual question based on your understanding of slopes. Many students get confused over here. Acha, this graph and this graph, the curvature is different, but that makes a hell lot of difference because the speed is increasing, and you can do the same analysis even for the later part. Hi Anthony. Good evening, bacha. Option B it is. Moving on to the next one. All right. So let's check the next graphical question, displacement time graph, and read the question. In the figure, there is a parabola. Parabola. From this graph, we can find which of the following. Hi, Siddhartha. Hello, welcome, Bachalo. Hi, Khushi, welcome. And guys, if you are from 10th to 11th moving students, so don't worry, I'll be doing something really special and cool for all of you this week. Stay tuned on the channel. Make sure you're hitting the subscribe. Although this particular session or this particular Zero to Hero series is mainly for the 12th students who are passing out or are already in 12th, just to make them revise. But yes, if you're a 12th to 11th moving student, you can still watch it. No problem. But remember, there is a special thing coming up just for you. S means displacement, bacha. C? Okay. So first of all, if you draw a tangent, the slope over here is 0, and the slope gives you nothing but the velocity. That means velocity is 0. If you notice, the velocity increases and it is parabola. Whenever it is parabola, remember acceleration is constant. So acceleration is constant, starts from rest. That's option C, of course. Done, done, done. That's it. You have to take the clues, take the hints. Body is moving with uniform velocity? No. If it was moving with uniform velocity, guess how the graph would be? If it was moving with uniform velocity, the graph would be like this. Body is moving at uniform speed, same thing. Both of them will have the same kind of graph. Body is not moving at all, then the graph will be like this. These are all displacement versus time. Displacement versus time. Okay? So if the body is not moving at all. Cool. Shall we move ahead to the next one? Oh, what do we have? Okay. So we have two graphs for two particles. They are making some angles, 30 and 60 degrees. This graph is basically velocity time. So let me just mark it right over here. This is velocity. This is time. And the question is relative velocity is asked at any time. So first, my question is, what does the slope of velocity versus time graph give you? What does the slope of velocity time graph give you? Put it up. Mechanics is weak, Himanshu. I would say follow the 11th standard regular series. It's there. It's called as the nurture series. Just go through the playlist tab, home, about, playlist. Just go through it. You will see 11th standard physics. Open it up. You will see detailed classes of acceleration. Very good warriors. It's going to be acceleration. So there are two particles. So for particle 1, the slope will be tan theta. So A1 will be tan 30. Tan 30 is 1 by root 3. And for particle 2, check this out, particle 2, angle is 60. So it should be tan of 60, which is just root 3 meters per second square, meters per second square. Question is, find the relative velocity. So V relative magnitude wise will be modulus of V2 minus V1. What is relative? A12 is A1 minus A2. V donkey monkey is V donkey minus V monkey, right? That's what I told you. So V2 minus V1. Now, how do I find this? When I know acceleration, kinematics. I just taught you kinematics, use that. So what is V2? V is initial plus A into T. So it will be nothing but initial velocity, which is 0. How do I know that? Check here. Velocity time graph. Initial velocity for both of them is 0. So just put it over here. Plus A2 into T. Oops, sorry guys. Yeah, this is V2 minus V1. V1 is nothing but initial velocity plus acceleration into time. More put. So A2, A1, T, T. Okay, so T can be taken out. So it will be nothing but A2 minus A1 into T. Now A2 and A1, I think I know it from here, root 3 minus 1 by root 3. So it will be root 3 minus 1 by root 3, the whole thing into time. Now this is bigger, this is smaller, so no need of modulus. So root 3 will become 3 minus 1, taking LCM guys, by root 3 into T. 3 minus 1 is 2, so 2T divided by root 3. So do I have it somewhere? Yes, I have it as option B. Very good IIT aspirant. Very good Anandini, Joyce, Anthony, Bharti. Very good, I don't know, very good. So many people. Hello, Parmark. Oh my God, what a name. Esmeri. Where are you from, bacha? Little bit difficult name for me to pronounce. Okay, so moving on to the next one. Okay, great. Let's see how many of you can do this question based on probably calculus, because I can see some acceleration is alpha into x square. Velocity is along x-axis. It decelerates. As per this law, what is the distance at which the particle stops? Let's try to imagine what is exactly happening. So it starts with certain velocity and it decelerates and stops, and it moves certain distance x because the deceleration is opposite to its, or acceleration is opposite to its velocity. Oh, you're from Turkey, Palmark. Nice to see you guys from Turkey and different parts of the world. Welcome all my lovely warriors. So let's try to solve this. First of all, whenever you see some acceleration is variable, you should quickly remind yourself that most likely it will be a question on derivatives or some kind of integration. You can see that there is some initial condition given. The particle is projected with certain velocity. Also, it's mentioned that it stops. So these conditions usually might become the limits of such an integration. Okay. Now, let's try and solve this. Acceleration, velocity, distance, time not given. Okay. So, how about writing acceleration by definition is dv by dt, but it is clearly mentioned it is decelerating. So the value of acceleration which I will substitute, which is alpha x square, will itself be negative because of that deceleration word used. So the derivative, rate of change of velocity, is negative because it's decreasing, because it's decelerating. Cool, let's try to solve this. Oh, I have a problem. I have x, I have velocity, and I have time. I cannot do much with it unless, no, some of you are saying, sir, v square is u square plus 2s. Guys, I can't use kinematics. Why I can't use kinematics is because it is only valid when acceleration is constant. The moment acceleration is variable, it has to be derivatives and integration. That's the reason why I stressed on the word. The moment I saw these variables, I thought about derivatives and integration. Okay, not about kinematics. So you cannot solve this by kinematics, keep this in mind. Now, I think I should use my chain rule. Remember, I just told about this in my notes right over here. Let's go back. See, acceleration is dv by dt, dv by dx into dx by dt, which is v dv by dx. So you can write acceleration, if you don't like time, in terms of position and velocity as v dv by dx. Just told you some time back. So how about using that over here? Yep. So I don't like v dv by dt, so I'll use v dv by dx. This is using your chain rule, of course. Using your chain rule. Now I feel I can do something with it. Bring this dx here, and maybe, I don't know, I can bring that alpha over there or something like that. So this will become minus alpha x square dx is equal to v dv. Once I get it in this form, v is on one side, x is on other side, I feel I can integrate this now. When I integrate, like I told you, limits are important. So initially the velocity was v naught. It just started at that point, so displacement is 0. When it moves, it stops after some time. So the final displacement is x, final velocity is 0. That's what it is. Everybody cool? Okay, so let's do this. So this will be equal to minus alpha. X square's integration is x cube by 3. So x cube by 3 minus 0 cube by 3 standard integration is equal to v's integration is v square by 2. So 0 square by 2 minus v naught square by 2, of course. Shift it around. Let's see, what do we get? We'll get minus alpha x cube by 3 is equal to 0 goes minus v naught square divided by 2, minus minus go. I think I need to find distance, so x cube will be nothing but 3 goes on the top, 2 comes below, 2 comes below, v naught square on the top and alpha over here. So x will be 3 v naught square by 2 alpha whole raised to 1/3. That's option D. Yep, option D. It's 3 by 2, v naught by 2 alpha. Now guys, B option does not have square of v naught, be careful. So there is a v naught square, there is a small difference between option B and D. Be little bit careful. It can mislead your eyes, and that's what happens many times. You mark this in a hurry. That's what happens. That's called as a silly mistake. That's called as a silly mistake. Let's move on. Yep, option D. Okay, this one is an easy one. Okay, Bharti, happens. So learn from this. It's okay. It's okay. Make mistakes, but learn from it. Okay. Body is projected at 30 with the horizontal. The air offers resistance and it is proportional to the speed. So resistance is proportional. Which of the following is correct? Usually we do not have air resistance, and we see that things are very simple. Time to go up, time to go down, parabola is symmetric. Everything is very simple. But what happens the moment you see that there is air resistance? Think about it. Okay, option D, really? Deepak, I'm a teacher, I'm not a bodybuilder. What will I do getting six-pack? And what is the use of having a six-pack, teacher? Okay, I will look good, fine, great. What is the use? You please tell me, Deepak. Okay, D or C? Okay, guys, the correct answer is actually C. Actually C. Now, very good, some of you got it. I'm proud of you, Srimati, MK, who else? Hema, very good, I don't know. So I'll tell you why it is C. First of all, it's clearly mentioned that resistance is offered. So if resistance is offered, what does it mean? If you throw it with certain velocity, it reduces the speed and the force is also more, and when it reaches on the top, after that, speed is less, so the force is also less. So resistance is less over here. So here there is resistance is more, and here resistance is less. So the force here and here are different. Hence the velocity is more here in general, and here the velocity is less in general. Even the speeds are not same. So will it be symmetrical? Definitely not. Time taken? Definitely not, because speeds are different, forces are different, accelerations are different. Will the sum of energies be same? No. Reason, there is resistance. It will suck the mechanical energy. It will suck that mechanical energy. It will not remain conserved. Keep this in mind. Cool? Let's move ahead. So the only thing which will be correct actually is that the velocity actually at the topmost point will be horizontal. That is the only thing which would make sense. That's all. Nothing else will be correct. Let's move to the next question. Figure this out. A ball is projected from the ground at an angle theta with the horizontal. After 1 second, it is moving at 45 degree. After 2 seconds, it is moving horizontally. What is the velocity of the projection of the ball? Interesting question. Let's try to solve this, figure this out. A ball is projected from the ground at an angle theta. So this is basically theta, this is u. It goes like this, like this, like this, like this. So at some instant, it makes 45 degrees with the horizontal. So that means this velocity v1 makes, or this velocity v1 over here makes 45 degrees with the horizontal. After this is at t is equal to 1 second. At t is equal to 2 seconds, it moves horizontally. So this is t is equal to 2. This is the final velocity. Very nice. 10 root 5 is it? I don't know, Anthony. I need to figure it out. So let's try to solve this part by part. Usually in these kind of questions, there are two concepts. Velocity in y direction changes because of g in y direction, because g is down. And in x direction, velocity will not change because there is no acceleration in the x direction. So let's try to use these concepts. So probably for this one first, this velocity will also have two components, like you can see over here, one this way and one this way. This will be u cos theta, this will be u sin theta, of course. So everything generally in y I will solve. So at 2 seconds in y direction, I can say v is u plus at, vy is uy plus ayt. Final velocity is 0. Check this out. Entire velocity is horizontal. There is no y component at all. So that's why that's 0. Uy will be u sin theta. Acceleration is minus 10 into t. So, t is also given. T is how much? 2. So just put 2 over there into 2. So u sine of theta is equal to 20 meters per second. Okay. Same logic what will apply over here till 1 second. Same equation vy will be v1y will be equal to uy, which is again u sine theta, minus 10 into 1. Now u sine theta is 20, so it will be 20 minus 10, which is just 10 meters per second. That's velocity of 1 in the y direction. I'll tell you what, if you look over here, this is a special angle, 45 degrees. So technically speaking, if v1 is here, this is the vertical component and this is the horizontal component, and this is 45 degrees. Check this out. If this is v1y and this is v1x, v1y, if I tell you it is 10, how much will be v1x? How much will be v1x? Think about it. Obviously 45, 45, isosceles triangle, this will be also 10. Everybody understands this? v1x will be also 10. Now, whatever horizontal velocity is here will also be the velocity here, because x velocity is always constant. Velocity in x is always constant. Hence, I can say u cos theta is also v1x, which is also 10. I got u cos theta, I got u sin theta. I know what to do next. It is fairly obvious now. Think about it. I know u cos theta, I know u sin theta. So obviously u square sin square theta plus u square cos square theta will be, this square is this 20 square and this square will be 10 square. 20 square is 400, 10 square is 100. Sine square plus cos square is 1, so it will become u square into 1. So u square will be 500. So u will be root 500, which is 10 root of 5. That's the final answer. 10 root 5, which is option C. Done. So it's a brilliant question which involves use of kinematic equations in a particular direction, also makes use of geometry a little bit, also makes use of the fact that velocity is same in a projectile motion along the horizontal direction because there is no acceleration, and it's also using a little bit of trigonometric identity over here to make that mathematical manipulation. What a brilliant. Sir, why can't we put u sine theta as 0 in horizontal? Because it is given that it is projected with some angle. So that's one. And u sine obviously will be there. If you are projecting at some angle, there will be two components of it. So unless theta is 0, u sine won't be 0. You're throwing it. How can u component, sine theta component be 0? It has to go up. Let's move on. All right. So Kaushik, I just explained it again, just a little time back. I did a small recap over there. Hi Uma, long time. Just if you want, Kaushik, please replay it. You will understand it. It's just a matter of you trying it on your own, that's all. Can we use u sine theta by g is equal to 2? Yes, Ninja Warrior, you can use that. You will get the same thing. Even if you use u sine theta by g is equal to 2, you will get the same thing. But you will only get till here. What after that? Do you know theta? The problem was I don't know theta. Hence, we need to solve it by some different method. So that's why I use these equations. That's why this data was given. Else, why would this be given? Okay, think about it. Let's move on. Okay, let's try to figure this question out. Two bikes traveling in the same direction move at the same speed of 30. So, bike 1, 30. Bike 2 also 30. They are separated by a distance of how much? 5 kilometers. There is a car which is coming from the opposite direction. So there is a car which is coming in the opposite direction with v speed, and the time interval between these two bikes. So imagine you're going this way, bikes are coming this way. So you cross the first bike till you meet the second bike. The time interval is basically 4 minutes, but everything is in hours and all that. So it is 4 by 60 hours, which is basically 1 by 15 hours. So the question is, what's the speed of the car? Now, we all know that if you have relative distance, that is nothing but your relative speed multiplied by the time that you take to cross it. Time is already known, it is 1 by 15. Distance is also known. For the car frame, the bikes travel how much? 5 kilometers. If you sit on the car, bike 1 crosses you, the next bike comes after 5 kilometers. So that's the relative distance between them. Now, what you need to do? So, the next part is relative velocity. Achha. Car is going this way, bike is coming opposite. So what's the relative velocity? Come on, what is the relative velocity? Think about it. What is the relative velocity? Obviously, it's going to be v plus. It's going to be v plus 30. Excellent. Excellent. Got it, guys? Very good. Now just do the math. It is nothing but 75 is equal to v plus 30. So naturally, v is nothing but 45. That's the final answer. There you go. That's it. Very good, very good. Just 1 second, guys. Hello, guys. Am I audible? Am I visible now? Hello, guys. Hello, my warriors. Can you hear me? Can you see me? Okay, so sorry guys for that brief interruption. Let's continue. So sorry for that. Okay, so the velocity comes out to be 45, so I think it should be right over here. There you go. That's option B. Let's move on to the next one. Okay, so we have a person standing on a road, has to hold his umbrella at 30 degrees with the vertical to keep the rain away. Okay, he throws the umbrella and starts moving. He finds the rain's drops are now falling vertical. So find the speed of the raindrops with respect to the ground. Okay, let's move on. First part says that he has to hold the umbrella 30 degrees when he's standing with respect to the vertical. That means that the velocity of the rain must be making an angle of 30 degrees with the vertical. That's the first hint from the problem. The second hint from the problem is when he runs, the raindrops are hitting his head vertically. That means the rain's velocity as perceived by the running person is vertical. So VRM is vertical. VRM is vertical. That's the second thing. And we all know VRM, V12 is nothing but VR or V1 minus V2. So VR minus VM. Now if you notice, it is a vector addition of two things. Subtraction is addition at the end of the day. This vector plus this vector. VR vector is here. So if I add one more vector, which I call it as minus VM, this and this, A bar plus B bar is C bar. VR plus minus VM is VRM. Done. Triangle is completed. 90% of the times in Rainman problems is just a triangle, simple vector addition, simple trigonometry and geometry. If VM is here, obviously guys, minus VM's minus is VM, which is here. This is the negative of these vectors, interchangeable. Now it's given, he's moving at 10. So if this is 10, obviously this is also 10. Now you can see right over there, sine of 30, because that is going to give me this divided by this will be nothing but 10 divided by VR. So VR will be 10 divided by sine 30. Sine 30 is half, so it will become 20. That is option D. Done. As simple as that. So most of the times you don't have to use complicated formulas. No need of complex maths. Most of the times it is simple triangles. Always draw the scenario and try to make the triangle, and remember this is the most important equation. V12 is V1 minus V2. VRM is VR minus VM. That's it. Okay. A is dropped from some height. B is projected in some direction. So from the same height, then which of the following is correct? So particle A is dropped from some height. So it hits the ground somewhere here. And the other particle is thrown from the same height with certain speed. So it's going to go like this, I guess. It's going to fall here. So the question is, which one will hit with more speed or less speed, or time taken, which one will be more? Is it with respect to the ground or man? Which one? VR will be with respect to ground. So whenever you see single subscripts, it is always with respect to ground. It is an unsaid rule. So when I don't put anything, it is basically ground. When I don't put anything, it is actually ground. So that G is there by default. Okay, let's try to figure this out. Yep, I think many of you remember the time taken to fall by just a simple drop is root of 2h by g, and the velocity here is nothing but root of 2gh. That's the velocity. Here what happens, the horizontal velocity remains. So 5 will remain. Apart from that, it will get one more velocity, which is root of 2gh. So the resultant velocity will be more than root 2gh. So velocities are not same, but time I had given you for this also, it is root of 2h by g. It is same. This is also time, this is also time. So you can see both the times are same. So hence the option is C. Simultaneously they will hit the ground. That's it. Next question coming up on your screen. There is some person who gives a situation to a student where there are 4 particles and velocities relative to each other are given. Find VDA. This is a very tricky question if you don't know the correct method. You will unnecessarily confuse yourself if you try to visualize it. Whenever multiple frames are there and the velocities are given with respect to each other, use a simple trick which I am going to show you now. Already had shown you in the notes, but still. This is north, this is east, this is west, this is south. Let's say this is x, let's say this is positive y. Let's see what and all is given to us. Velocity of DC, VDC, is 20 towards north, means plus y, so plus 20 j cap. VBC is towards east, so VBC is 20 I cap. And last one, VBA, is towards south, so VBA is minus 20 j cap. 3 things given to us. Now the last thing which is asked is velocity of DA, VDA. Remember I had told you, whenever you have to find velocity with respect to something else and something else's velocity is given with respect to something else, start with the first subscript letter, VD. So start with this. Now in between, many alphabets are going to come in order. See, where is VD? Oh, it's here. VDC is given. So put C here. Next, since I ended with C, start with C first. Now see, where is C? Oh, C is here, but VBC is there. So I don't need VBC, I need VCB. So VCB will be negative of this, so it will be minus 20 I cap. If this is exactly opposite but same in magnitude. So how about putting this CB over here? Plus, since I ended with B, start with B and it ends with A, which is our final alphabet here. This is A, this is A, this is D, this is D. That's it. That's how you need to go in order. Now just substitute. VDC is plus 20. VCB is minus 20. Oh, but this is I cap and this is J cap. And this one is nothing but minus 20 J cap. J cap goes with J cap, cancels, so it's just minus 20 I cap. Minus 20 I cap is right over there. Left side, west, obviously, minus 20. Option D. Very good. Bharti, very good. I don't know. Excellent. No, it's not C. A lot of people make many silly mistakes out here. So you can see that the trick over here is changing from one frame to other. Follow the order. This is here. The last alphabet comes towards the end. In between, a D to C, C to B, B to A. Keep jumping properly. Hi Meghaji. Oh, looks like you're late, but it's okay. You can watch the replay later on. Okay. Now there is an artillery piece which consistently shoots its shells. It's not shields, it is shells. There is a double L and single E supposedly, but with the same speed as the maximum range and has a maximum range R. To hit a target which is R by 2 and on the same level, the angle of the gun should be. Yeah, that order of the letters is very important, IT aspirant. Let's try to do this. First of all, that artillery is projected such that the range is maximum. So I know this should be 45 degrees with some speed and it hits right over here. This is R and we know that R is nothing but U square sine of 2 times of 45 degrees divided by G. That's what it is. Second time what is happening? The range is different. So the question is, what's the new angle going to be? So for R by 2, I can say it is U square sine 2 theta. I do not know what theta is by G. But wait a minute, I already know the value of R. R is this whole thing. So how about putting it over here? So I'm just going to use that R value, which is U square sine of 2 times of 45 degrees by G. And this 2 comes over here as it is. This is U square sine 2 theta divided by G. A lot of stuff gets cancelled. So what remains is sine of 2 into 45, which is 1, okay, by 2 is nothing but sine of 2 theta. Sine of this is basically going to be 1. So this is 1 by 2. That means 2 theta is 30 degrees. That means theta is 15 degrees. That's the answer. Option A it is. Let's see how many of you gave the correct answer. Very good, IIT aspirant Thana. Excellent day. Very good. Excellent day, guys. Very good. Proud of you guys. So this is how you need to solve it. It was completely based on the range formula and simple manipulation. Use two scenarios, 2 times formula, substitute, you will get the answer. Next question. The position of a particle with respect to time along the x-axis is given by this value, where x is in meters, t is in seconds. What will be the position when it achieves maximum speed along that direction? Let's try this out. Okay, so according to the question, position is given. Question is, when is the maximum speed going to be achieved? So I think we need velocity. So how do you find velocity from position? Obviously derivative, dx by dt. So that means derivative of this guy, which is 9t square minus t cube. So the derivative of this guy will be 9 into 2t minus 3t square. Okay, this is going to be nothing but 18t minus 3t square. Now once I get the velocity, think about it. The velocity graph will be a parabola because there is a square term. So if you draw it, it will be in fact inverted u because this minus sign. Whenever the square term has a negative coefficient, it's an inverted parabola. Not just that, when the velocity is going to be maximum, that's where the slope will be 0. So first find the slope. So what's the slope going to be? The slope is going to be 18t. Oh, sorry, the derivative of that, my bad. So sorry, the slope of this is the slope of velocity, be careful. So it will be dv by dt. So 0 will be equal to, because slope has to be 0, derivative of that will be 18 minus 3 into 2t. So basically you will get 60 is equal to 18. So t is equal to 3. Just check this out. So once I get this, I think I have found the answer. Oh, but they have asked what is the position. So position they have asked. So they have asked this x. So basically x will be equal to 9 into time is 3. So 3 square minus 3 cube. 3 square is 9, 9 nines are 81. 81 minus 27, which is going to be 54. That's the answer. So we have it. Option A it is. Excellent. Some of you got it. Bharti IIT aspirant, very good. Good evening, Venkat. Hello, Maram. Yep. Oh my God. Thank you, God is love. Thank you so much. Yes, Joyce Xavier. It is. So concepts were, first is knowing that you need to find velocity to find when is it maximum. Second concept was, once you see it's a quadratic equation, you know it's a parabola, and at maximum anyways, the derivative is always 0. So you found the derivative, which is the slope, is 0. Found that time. But the question was not to find the time. Okay, the question was to find x. So you had to substitute 3 in this equation to get the final answer. Next question. X and the y components. The x and the y components. Thank you, Samyukta, so much. Can you use maxima minima concept? Exactly. It's the same thing, Girish, at the end of the day. Even if it was not a parabola, I would still draw the slope and equate it to 0, which is derivative. Yep, it is, Girish. Okay. The x and y coordinates of the particle are this and this, where x and y are in meters, t is in seconds. The acceleration at 2 seconds is how much? Okay, let's try to find this out. The funny part about this question is there are 2 coordinates, so I need to be a little bit careful. If there are 2 coordinates, that means there are 2 components of everything. So let's find it out separately. So x is given. So velocity in the x direction will be derivative of x in with respect to time. So derivative of x, that means d by dt of, what is it, 5t minus 2t square. So the derivative of this will be 5 minus 2 2s are 4, 4t. So that's vx, but I think we need to find acceleration. So acceleration in x will be derivative of velocity with respect to time. So it is basically the derivative of 5 minus 4t. Derivative of 5 is constant, so it's 0. So minus 4, derivative of time is just going to be 1. So it's just going to be -4. That's your acceleration in the x direction. Similarly, for y-axis, Vy will be dy by dt, just like Vx was dx by dt. This is y, so y. So which is derivative of 10t. So it is just going to be 10. Now that's the interesting thing. This is constant. Naturally, the acceleration in the y direction will be 0. If there is no change in the velocity, why will there be any acceleration? Last thing, find the net acceleration. So one component is 0, the other component is -4. So obviously the acceleration will be just -4 only in the x direction. Y component will be 0. That's it. Option D, no, it is option C, guys. Looks like many of you got it wrong again. Yep, just C, that's it. You can see that right over here. One component is 0. So it doesn't matter, only one of the component will come. Okay, next question coming up on your screen, again on derivatives. Many of them are, by the way, PYQs. I have not mentioned the year, okay, because sometimes people get scared, oh my god, this is a PYQ, I will not be able to do it. But it's okay, it's this mindset which is there. Now two cars are there which start from the same point, same time, straight line. Positions are given by this and this. At what time do they have the same velocity? Position is given, velocity is same. So from position, first find velocity. So the velocity of car P, or this particle, will be derivative of this position with respect to time. So it is derivative of AT square plus BT square. So that is going to make it nothing but 2AT plus, oh sorry, it is not AT square. I'm so sorry, guys. Just one second. Let me just erase this. It was just AT plus BT square. So derivative of this will be just A plus 2BT. That's the first step. Next step, this guy, the second particle. So velocity of particle Q will be dxq by dt. So it will be derivative of ft minus t square. So vq should be ft, right? ft's derivative will be f minus 2t. It's clearly mentioned when will their velocity be same. That means these two, that means this should be equal to this. So equate both of them. So a plus 2bt is f minus 2t. Rearrange. So 2bt plus 2t is equal to f minus a. Time is common. So f minus a divided by, you will see 2 into b plus 1. Just check this out. 2 into b plus 1. Do I have such an option? I think so, guys. Where is it? Option D, yes. F minus a upon 2 into b plus 1 or 1 plus b. One and the same thing. Yes, option D it is. So it's not as difficult as it looks like initially. It looks like, oh my god, some crazy equations. When is the velocity same? But if you follow the procedure, once you do few steps, you understand, oh, you have to just equate them and solve it to find the time. It just looks difficult initially. Next question. Ready, guys? All right, let's do the next question. Joyce is very happy about solving these questions. Let's do this, guys. Okay. First of all, what is this? A car starting from rest accelerates at the rate f through a distance s, then continues at constant speed for some time, and then decelerates at some other rate to come to rest. Total distance is 15s. S is not seconds. S is some distance. What is the relation between s and time square? Okay, let's try to draw this first. Without drawing, it might look little difficult. So it starts from rest. So velocity is 0. It travels at the rate of f. So f is the acceleration through a distance s. So this is basically s. Then it continues at constant speed. So here it gets some velocity for some time. Okay, how much time does it take here? Let's say I call it t1. How much time does it take here? Distance, I don't know. I'm just going to call it s2. Okay, this is time t2. And same velocity, it continues here also. And finally, it comes to rest. But here, it decelerates with f by 2. and that's it. And this distance, I'm just going to call it S3. Okay, and this time T3. Cool. If the total distance traveled is 15s, then how much will it be? Okay, let's try to solve this question. First of all, well, let's see what and all we can do. For this part, I think we need to find the relationship between the times and the displacement, because finally we want answer in terms of only the t, because the unit continues for a constant speed for a time t only. Oh, so T2 is basically t. Achha, so I think we need to find the relationship between all of them somehow or the other. Okay, let's try to do this question. For this part, for the first part, okay, for this part, let's try to do this. So V will be equal to U plus F into T1. So therefore V is equal to F into T1. That's number one. Also S is equal to, okay, this is one equation which I got. S is equal to ut plus half into acceleration into T1 square. So therefore S is ft1 square divided by 2. This is another thing which I got. Okay, I'll just keep it as it is. Now let's focus on maybe this part, because this is acceleration, that is deceleration, so maybe things could be easy, or maybe just this one. Let's just try this out. What happens for this one? Okay, so here the velocity is constant, so I can just use velocity is distance by time and stuff like that. So distance 2 will be just velocity into the time. Velocity I know from here is nothing but ft1 into t. So this is just displacement 2. Okay, I can just keep it over here, nothing much, right? Okay. Oh, sorry, this is not t1, this is t2, my bad. This is ft2 into t. Okay. Oh, but I know t2. T2 is also t. Just check this out. Oh, sorry guys. One second. I'm so sorry. I made a mistake over here. Velocity into time, this is fine. V is ft1, so this is ft1 into t. Okay, this is okay now. I think this is fine. Okay, t1 into t. Yes, t1 into t. Now for that part, I can just think of it is starting from rest here and coming to this point with some velocity v, traveling distance s3. There is this principle called as reversibility, meaning if something is decelerating and stopping, I can make this time go backwards and make it look as if it is accelerating and achieving the same velocity in the opposite direction. Think of it, when you throw something up, it decelerates. If you rewind it, it accelerates. Same time, same displacement. So how about solving it for this that way? So you will notice that your V or V square is nothing but U square plus 2 into acceleration. Acceleration is F by 2 into displacement, which is S3. Interesting. So this is F, guys. Okay, this is F. Now V from here is ft1. V from here is ft1. Interesting. So how about using that over here? So this will be F square T1 square. Okay, I've just used this guy right over here. Okay, I've just used this guy right over here. Okay, that's all I'm doing. Is equal to 2 cancels. It will become F into S3. Okay, F into S3. If you want, I'll write it properly. Just one second. S3. ft1 square. ft1 square is 2s. So ft1 square is 2s. So 2s. And there is one f over here. So just put it as it is fs3. So naturally I got s3 is equal to 2 times of s. Interesting. I just got the value of s3 also. Got it, guys? What and all have we found out? Check this out. ft1 square from here is 2s. So I put that 2s from here, and one of the f was remaining. If you want, I'll put it in the same color so that you know while you're looking at the solution what exactly we have done. So ft1 square is 2s. So So this I got it from here. That's all. Okay. Now S3 also gone, this also gone. So I think it's time to add them up and see what do you get. S1 plus S2 plus S3, the total distance is 15s. Total distance is 15s. S1 I know is just S. So just put S over here. S2 is not known. Oh, it's here. Ft1 into T. Ft1 into T. S3, I just got it as 2s. So just put 2s is equal to 15s. Now s plus 2s is 3s. It goes there. So Ft1 into T will just become 12s. Okay, fair enough. So I got this. I have few more things. Okay. So how about taking this and this maybe and dividing it? How about taking this and dividing both of them? Okay, let's try to divide both of them. So see, what do I get? I will get Ft1 into T is equal to 12s, and at the bottom I will have Ft1 square by 2, and here I will just have s cancels, 2 goes on the top, ff cancels, t1 cancels, so I will have 2t by t1 is equal to 12. So basically I got t1 is equal to t by 6. Interesting, I got the relationship between the times. That's what I needed. Once I get T1 substituted here, so S will be equal to F by 2 into T1 square. T1 square is T by 6 whole square. So it will be F T square. 6 square is 36. 36 into 2, 72. So that is your final S. Yep, there it is. Option D it is. Option D it is. Option D, guys. Brilliant manipulations. It's just all about equations and just going with the flow. Okay, what will I see? I don't know when I started solving how am I going to do it. It's just you have to go with the flow. I know this, I know this, I know this. Oh, this is related to this, this is related to this. Maybe I can divide them. I can find the relationship between the times because T1 was not a known value. So I wanted to get rid of T1. That's why I divided it. That's why you can see I divided it. That's all. Okay, brilliant question it is. Okay, and that's it. That's the end of the class, guys. I hope you guys had a great time. But before that, remember the NEET crash course and the JEE crash course links are there in the description box, where you will get complete access of interactive classes with recordings, with PDFs, with notes, and every chapter comes with an assignment, and you have 20 all India level mock test series with all India rank comparison and lots and lots of live support that you get during the class. All of this is for 2,700. Tomorrow onwards there will be a price revision. There are many courses whose prices are going to increase, not by big amount, but maybe 500. Some courses are increasing by 1,000 rupees. Some courses are increasing by 200-300 rupees. So why do you want to spend that much, extra money? So make sure you check out the link which is there in the description box. If you want, I'll just show it to you once right now. So if you go down over here, you will see it's right over here. All the links. Okay, I think the crash course links are not yet there. Don't worry, guys. I'll make sure that the crash course links also come. Okay, it should have been there, but these links are for the 11th to 12th moving. That's 2023. This is for 10th to 11th moving. I'll just add the crash course links as well. MK, if you're already part of crash course, very good. You are taking the best of the two worlds. So because all the problems we do in the crash course are completely different. The methodology only is different. Assignments have very different questions. So you will have the best of both. Very good. Keep it up. Rotation motion also I'm doing it very soon. H.C. Verma is the best book, IT aspirant for JEE. Thank you, Joyce, so much. And guys, have a great time. There is no doubt section for crash course. There is. If you're attending the class live, obviously if you watch it recorded, you missed it. So then you will not get the doubt solving during the class. But if you go for the better version, there is another version where you can get doubts even after the class. then you can ask unlimited doubts even after the class is over. Okay, cool. SBT book, I'm not sure, bacha. I'm so glad, Joyce. Okay, bye bye guys, have a great time. See you again tomorrow and day after tomorrow in this series, and a lot of sessions also coming up for 10th and 11th moving students, definitely. Okay, thank you very much. Bye bye, take care. Hasta la vista.